Okay, this video is going to be on the rest of the exponent rules. The first one is power to a power. So power to a power. And this rule is when you're got an exponent raised to an exponent, what you're going to do is you're going to keep the base. You'll always keep the base and multiply exponents. So power to a power, you keep the base and multiply exponents. So here's what these ones kind of look like. What if I have x squared raised to the 10th power? That is like saying x squared times x squared times x squared times x squared 10 times, right? And so I don't want to write that out 10 times. So I use this shortcut of, instead of writing out 10 combinations of 2, I can just multiply the exponents. So that would give me x to the 20th. And that's the power to the power of the exponent rules. So we can mix this up and have them with numbers in there like 3x squared y to the third all to the second power. So when I do something like this where it's bigger and longer and you'll get harder and harder ones, you need to take each thing to that power. So you start with the 3. 3 squared is going to be, or 3 times 3 is 9. So I can actually calculate the number. Now with the x, it's going to be, it's to the second power squared, so that's going to be x to the 4th. The y, 3 times 2 is going to give me 6. Let's look at another one. They had some that got a little harder. Here's one that gets a little harder here. So 4x to the 4th, y all to the 3rd power, and then we're going to times that by 2x to the 3rd, y to the 3rd squared. Okay, so let's do one that mixes the last rule we had looked at in the video before where it was exponents, so, or multiplying, excuse me. So we know when we multiply, we're actually adding those exponents. Okay? So when we then do an exponent to an exponent, we have the rule of multiplication. So be careful of which one you're doing. These ones are both powers to the power, right? Then these two have to be multiplied. So we always, in our orders of operation, have to get rid of the outside exponent first. So I'm going to simplify both of these using my power rules. Then I can simplify more. So 4 to the 3rd. 4 times 4 times 4 is going to give you 64. All right, so then we're going to have 64, and then x to the 4th to the 3rd is going to be times those, so we're going to get 12. Y, it's like a 1, or you take y to the 3rd or get y, so you get y to the 3rd power. It's like a 1 times a 3. That simplified my whole first section. Now take the next one. 2 squared is 4. X to the 3rd to the 2nd is going to be x to the 6th. Y to the 3rd to the 2nd is y to the 6th. Now these are both simplified with the outside exponents gone, so these are just a multiplication problem together. So we start with 64 times 4, which I still got my calculator out because I can't remember that one. 64 times 4 is 256. So the numbers, you still do like the same process. X to the 12th and x to the 6th, you'd add those at this point because they're just multiplication. So this would be 18 total. I have 12 here, 6 here makes 18 of them. For y's, you have 6 and 3, so that's going to make 9. Okay, so that's my final answer is that one. 256 x to the 18th, y to the 9th. So we kind of mix both of those rules that we have looked at. Let's look at division. With exponents. The rule, I kind of hate writing a rule, is you're really going to keep the base and subtract exponents. But here's the tricky part about division. No negative exponents. You can't have negative exponents on these division things, so you have to be careful how you simplify it. Let's look at some basic ones. So if I have x to the fourth over x squared, subtracting these 4 and 2 from the top to the bottom makes 2. There's nothing negative, so we don't have any issues. This would be x squared. Another way to think of this, why are we subtracting? Where does that idea come from? That idea comes from if I have 4 of those on the top over 2 of them on the bottom, can you see that 2 would cancel and I'd be left with 2 on the top or up here? So this is in the numerator, right, because it's over 1. So we have x squared, 2 of them, x squared. So let's look at another one. What if I flipped those? If I subtracted my exponents, 2 minus 4 makes negative 2. Can't have that. So you have to understand how this works. It's going to be the opposite of this, right? You'd have 4 on the bottom, 2 on the top. So you can see that 2 of them will cancel on the top with 2 of them on the bottom, leaving 2 of them on the bottom. Basically, you subtract the exponents and keep them where there were more. Right? There's more, x to the fourth is bigger, so we keep the x on the denominator. Always do a placeholder of a 1 on top. You could have had a 1 over here, but we don't have to write it on the bottom. Have to write it on the top. Okay, I'm out of paper. Let me flip this over real quick. So let's look at, this is my third example. Maybe be x to the third, y to the fourth over x y to the 10th. So if I have something like this, this only has 2 letters. We look at each one separately. And I go, okay, where are there more x's, top or bottom? More on the top, so my x will stay on the top. 3 minus 1 would give me 2. So one of these canceled with one of those. Now I got 2 of them on the top. Where are there more y's? On the bottom. 10 minus 4 is 6. So 4 of these canceled with 4 of these, leaving 6 on the bottom. Okay, so that's our answer. Can't combine an x and a y, so we're done. Now let's look at how you're really going to see your problems, because this is the idea. This is something you've seen before, but of course I want to make sure you remember it. Okay, let's make it harder. Okay, so if I have something like this, 4/10, and then you have the x to the 7th, the y to the 3rd, z, and then x to the 5th, y, we have numbers in here. Well, it's a fraction. The numbers don't have exponents, so we don't have any exponents. The rules are the same as if it's a fraction. How can I reduce 4/10? Well, I reduce it by dividing both the top and bottom by 2 and get 2/5. So I just reduce the fraction. A lot of people try to subtract them and do weird stuff. Just reduce your fraction. Now look at your x's. 7 on the top, 5 on the bottom. So we know our x's have to be on the top. 7 minus 5 is going to give you 2 on the top. Then look at your y's. 1 here, 3 here, so the y's will be on the top too. 3 minus 1 is 2. And the z, it's all by itself. There's no other z to cancel it with, so it just stays where it's at. And that's your final answer for 4. Okay? Now let's look at some negative exponents. And the way I like to teach negative exponents, man, that is some ugly handwriting. I like to teach negative exponents like, okay, it's like you subtracted yours and didn't think about where they should be. So then you end up with a negative exponent. So the rule that I'll give is move from top to bottom or bottom to top. And why didn't I use the word denominator and numerator? Because I guess I should have, but because they're longer to write maybe. Move from denominator to numerator or numerator to denominator, and lose the negative sign. It's like my note, don't forget to lose that negative sign. So here's an idea or an example of this. If I have x to the negative third power, it's like I subtracted them and it really should have been left on the denominator. I messed up, kind of, is the idea. Of course, but then they throw a ton of them at you like this. We are not allowed the negative exponent, so we can't leave it this way. We have to think of it as, okay, I move it from, right now, it's in the numerator. I'm going to move it to the denominator and take away the negative. I need a placeholder of a 1 in that spot in the numerator, but you really don't need, you aren't flipping it necessarily. Let me show you what, so anyway, it moves to the denominator. What I'm meaning by that, what I was trying to think of, I didn't want to make you messed up if it was something like this. The difference between those two is you have another number next to this one, but the other number, does this number have an exponent? 3? No. So 3 doesn't have an exponent. So we're going to leave it where it's at, and x to the negative 2 has to move down and lose the negative. So not all the things are going to have negative exponents, and you only can move the ones that have a negative exponent. Okay, so let's look at a harder one. Okay. Let's try negative on that one too. Okay, so if I have this one, it's kind of like everything we've been doing. It's got, so for this one, all right, sorry, I got a ding and I thought I was missing logging into your class from one of my classes, so I was like, had to check the time. Okay, so let's look at the fraction. Doesn't have any negative exponents, so we just reduce it to a 1/2. I don't really have to write the 1, but I can. Let's look here. This is an x to the negative third, and this is a 5. So you could think of it as -3 minus 5. That's kind of hard. I mean, you can do it that way. And then move your negative exponents around. But the way I like to think of it is this one, x to the 5th, needs to stay on the bottom because it's positive. But this x to the 3rd has to move down and lose the negative. Okay, now look at your y's. Y to the 4th stays on top because it didn't have a negative, and y to the 10th had a negative, so it has to move up top and lose the negative. So see how I just moved the x to the negative 3rd down and the y to the negative 10 up? Just move them wherever they're at. Now here I can simplify this more. The y's are next to each other, so that means times along with the x's. I don't have to write the 1, so I'm going to leave that off. So on the top I have y to the 14th, and on the bottom I have x to the 8th. So there's our final answer. Y to the 14th to x to the 8th. I got rid of my negatives. Now let's look at one that switches them up a little bit different. This kind of uses, let's see, let me write it out first. 2x to the negative 3rd y squared all to the negative 3rd power. And there's probably like 4 or 5 different ways you could do a problem similar to this one. You could do it like getting rid of the negative out here first and then getting rid of the negatives in here. What I find the easiest is to distribute this one, negative or positive, to each thing first, then see what you got. So basically I'm going to take 2 to the negative 3rd, so I get 2 to the negative 3rd. Remember, if you have a power to a power, you multiply. So negative 3 times negative 3 is a positive 9. And then on the y's, 2 times negative 3 is y to the negative 6. So now I got rid of that exponent. Now I can see these two are negative. They have to go from numerator to the denominator. So I'm going to leave the x to the ninth up top, and the 2 to the third and the y to the sixth move down and lose their negatives. Okay, that's my final answer. I could figure out 2 to the third. So 2 to the third is 8. So another way I could have wrote this is x to the ninth over 8y to the sixth. And it might make you write the 8 on my math lab. So I'm not really sure. Okay, so let's look at one last thing that kind of goes in with all these exponents, and that's scientific notation. And you should have learned this, I don't know, a million times in science class through high school. You should have learned it in math as well. So scientific notation is used for really big numbers, really small numbers, and guess what? It uses exponents. Hence the reason it's in this section. So let's look at one like a big number, and how do I write this in scientific notation? So let's say I have $160,000. Oh, I wish. And I wrote this in scientific notation. Scientific notation is all about moving a decimal, not zeros, moving a decimal. I want to write it to where there's one number in between, or one number on the left of the decimal. So right now the decimal's here, and I want to move it 1, 2, 3, 4, 5 times until there's only one number in front. I can then rewrite this as 1.6, leaving off the zeros, just including the numbers, times 10 to the, wait, how many times did I move it? 1, 2, 3, 4, 5, times 10 to the 5. Well, we know 10 to the 5th is going to be a big old number with lots of zeros times this, and it's going to move your decimals. So timesing by 10 is going to move your decimals. So that's it. That's, you add up how many times you move it. It could be a small number, and you have to move it the other way until you have one number in front of the decimal again. So this one, I'd move it 1, 2, 3, 4. So I'd move it 4 here, like this. So this one would become 2.34 times 10 to the, now I moved it 1, 2, 3, 4, but it has to be a -4 to indicate that I moved to the right. And that's the difference. Okay, so when I times by negative, it's going to move it this way, because it's really like 1 over 10 to the 4th, because we know negatives, we just looked at them, and that's the same as dividing. So, but we're lazy, and this is the only place you're allowed to write negative exponents is in the scientific notation. All right, so you will take them out of scientific notation, you'll put them in. That shouldn't be something that you haven't seen before, but the last one you may or may not have seen. So what if I want to divide two things in scientific notation? And sometimes you want to multiply them. And our rules with exponents is if you're multiplying, you're adding the exponents. Okay, if you're dividing, you're adding or subtracting the exponents. Same thing applies here. We can actually just divide the numbers, so that's 6, and we're going to times it by 10 to the this one minus this one. So what is 4 minus 6? Think about that one. 4 minus a -6. You'd add and get a 10. So the answer to this one is 6 times 10 to the 10th. All right, so subtract down to get your exponent, and negatives are fine in scientific notation. Divide your numbers, and that's all there is to the division. If you multiply them, multiply your numbers and add your exponents. But you don't do a ton of these type of problems, but you do some. You shouldn't say that. But that's kind of an overview of 5.1 and all of the exponent rules.